Okay, welcome back everyone to more Serenum programming. So I sent some more emails last time about the bug, and it turns out there's actually there's a language feature which will enable what I want to do in like the most easiest way possible, which is simply to embed a file at the very beginning of the program and then just get a pointer to its bytes. And so in particular, kind of Sam noted, if you include spatium, octatorum, escafio, mysprite, raw.mysprite at the beginning of the file, this will simply kind of embed it within the data section of the binary. And so today I want to go back to the Zig exporter, export the file as a bunch of bytes, do this to load it, and then immediately start drawing it on the screen. And this will avoid having to kind of create some other file. This will be the easiest way possible. I didn't even realize this was possible, but now we know it. A lot of work has been saved. A lot of time has been saved. Okay. So now I want to go back to, let's minimize this. Go back to our Zig program to output the thing. Where were we? We're in Serenum, and so we'll make this full screen. I think we're in the Serenum Sokoban, into the sprites. And then we want to look in this QRI to Brevis ingest. And I think we wanted like roof.zig. We should probably rename this. But yeah, the result of this program was to produce this thing. And so now we want to just replace all of this with the raw bytes. Last time we figured out if we just called this writer/write_all and just passed it the byte array, it will do that. And so we can actually do something even easier. We don't even need to format some kind of print statement. We can simply just record the bytes once we've decoded them. So let's see. So we decode all of the pixels and get the bytes with this call, and this should just give us back a root pixels should just be the pixels. Each of these pixels is themselves basically like a vector. A constant length array of U8. It really should be a vector. And so as we iterate through all of these pixels, what we want to do is, I wonder if I should like have an old version of this. Let's actually just like make an old and new copy of this. Oh, where are we? So let's write like QRI to QRI to raw bytes.zig, and then we can just edit this version. Yeah, that's not what I wanted. Okay. There we go. And I think this here is what is like the QI image here is what we originally want to do. I feel like we should just make this a bit easier. QI file name. There's some way in Zig of like passing in command line arguments. We can figure out how to do that later. But for now, we'll leave it like this. And then we're going to want to pass the QI image. I feel like all instances of root header we want to replace with maybe this QI will pass QI header. Okay, and then in here we can get rid of stuff. And really, like, okay, we're gonna have to like rename QI just to like some instances of it to sprite. So sprite file name. Sprite image. Then we get our sprite pixels. Okay. Yeah, so what are we going to want to do? We want to say the byte array current byte, well, we actually want another for loop. Call this K. Then we want to say in the byte array, the current byte index plus the K. Set this equal to whatever the pixel U8 was. Giving it that name is a bit silly currently. We just want to set that equal to the pixel. But we'll want to push up the current byte index by 4 each time we iterate through. And then we want to simply write all of these to the file. And I guess when we're printing these, just as like a debug, let's print like 10 of these, or let's print like the first 2 pixels just to see how it's behaving. Okay. So we want to do zig run QI to raw bytes. Okay, is this what we expected? I suppose we could actually just open up the roof.qi file. It's not compressed. I mean, that is compressed. What were the colors that we actually chose? If we do the Zig image viewer on the roof.qi, and we do this like color picker thing. Where is it? There's an easier way. We'll just do this simple way. Of course, we can't even zoom in more, but that's Microsoft for you. Okay, where's like the... we can't do this. What was it? We wanted to use like the picky image viewer. Wasn't it just like pixie dot fast release? Yeah. So if we do pixie fast release on what? Can we just call that on the new file? Yeah. Okay. We can finally actually see what I can zoom to an arbitrary length. Well, oh, it's incorrected. I can't even zoom more than that. Better than paint. More importantly, finally see. Let's say I run this again. Is this what we expect? So we expect the first number. Oh no, this is not exactly what we want. So I was expecting the first 4 numbers to be 14873582555, but that's not what we've got. And similarly over here. Yeah, where are the 255s? Why are these not repeating constantly? This is unexpected. Like what's actually happening with these pixels? Say we just printed out what these were. So we are seeing the 255s here. Why are they not repeating down the bottom? Yeah, like this is exactly what we wanted, was it not? Yeah, 14873. So yeah, our QRI decoder is working fine as expected. It's worked in previous projects. Why are these not getting written down here correctly? This can't be some conversion thing, surely. Let's say we open this Brevis image in ingest. Oh, okay, it's because it's printing this. Okay, now that we understand that, we can remove that line from, we can remove the top line from the file. No header needed. This is better. This is what we wanted. So just to check, the second pixel should be 233133. Yeah, great. Okay, that's now working. So now if we go to the Brevis image ingest, how do we check out the XXD mode of this again? Well, Emacs XXD mode. So MX hexel. So hexel find file. Read this image ingest. What on earth is this doing? Okay, I'm not sure what this like header up here is. This must just be like, who knows. But otherwise this seems to be correct, right? We have 55 bytes every 255 in those values. Going across the screen, we expect the colors to kind of remain the same for a bit. Then well, let's just see, like, what's 94 in decimal? 148, right? Okay, that's fine. So now let's just see what like the very final character of this is. It is an FF as well, which is what we want. Okay. Yeah, so let's run this again and then load this onto the Serenum. Now quit that, and let's just like give this a sensible name. So we want to do this Brevis raw image ingest to like roof.data. Even that name's not sensible. Roof sprite dot roof sprite, not roof spirit dot data. Okay. Let's copy this onto this Serenum and get that rendering. Okay. Where is our file reader? So this is where we want it to go. So yeah, in the RISC-V drawing, let's just put it. That's where this old Brevis ingest was. So we want to now do roof sprite.data. Okay. Yeah, let's eject this. And then we can get to the Serenum programming. Okay, get rid of this. Go back to here. Full screen. Okay, when it turns on. My keyboards have almost become tangled together. Okay, alright. So yeah, we want to go to the RISC-V drawing experiments, the codex here, and yep, our roof sprite data is here. Great. So now we can go back to like the texture texture.lbc, except we need to open this in read-only mode, in edit mode, which we have, and then we can apply SAM's thing. So we want to do this. Okay, let's see. And yeah, we call this roof underscore sprite data. Roof underscore sprite data. So roof sprite data. And what is it? So let's just do this in the easy way. So we want to do spatium excuse me. Spatium octet, come on, octet torum scapo, the name of the thing, or rather the location, and then what we actually want to call it. So let's call it like sprite data, sprite data. Save. Okay. Load in the roof sprite. Okay. So yeah, let's now use this to get the pixels on the screen. So I think all of this like init sprite stuff can go. this thing here that was calling the sprite itself is currently blowing out the stack, and so that can go. But also, like in Brevis, the notion of stack is different. So in terms of the drawing stuff, here we want to say let's just I'm going to say render the texture. So we get this, then and I think here we want to have a done loop. So here we want to say, have an I that's equal to 0, and then we're going to iterate the I over the length. I think we could actually make this roof sprite dot length. And then each time we want to, at the end of each loop, increase this by 1. And then we simply want to draw it. So we want to say, why am I even copying this? Just want to say, dereference the pix pointer. There's actually two things we want to do every loop. We want to increase that by 1, and we want to increase the pix pointer by 4. And then we want to just draw in the value. So we want to say pix pointer O. Last time there was issues with regards to try to like use like an array syntax with the pix pointer. So I think, because I was trying to remember why were we like defining two of these things, and then I remembered. But if we're already keeping track of this, there's no need to like, well, you need to like, we can just specify the 4 arrays that we need by like adding 1 each time. Because there's like, yes, we only kind of have, we have a single loop, but this like 1 versus, the fact that the pixels are 4 bytes means that there's some messy ways to do this, and we just want to do this in a simple way, especially because we're going to be translating it into assembly later. I think the easy thing to think about is for the for us to be doing this loop in terms of like pixels. Can we do an assert? So I want to assert that the length is equal to like 25, like 625 times 4. Which is what, just 2500. I'm curious. Let's just, like, I need to program with asserts. It's just like, it's the only sensible way of programming. Let's like check one of these backups to see if we had some like asserts in there anywhere. Do like assert. Maybe it's a different word. Oh, we do see like set region is number. We might just like print out something to standard out that just describes what's happening. So let's just do like assert that the length. I need the Dvorak keyboard so bad. QWERTY is ridiculous. Assert that the lengths are the same. So let's do we expected we just expected 4 times and we expect something and then the actual is this. And for the expected, we want 4 times 625, and for the actual, what we want is the roof sprite dot the dot the okay, and then assuming that's fine, let us actually just work with the 625. And then throughout this, we want to say so like the thing is like maybe it's actually better to just, since we're going to be doing this in assembly anyway, it may be better to just manually increment the pixel pointer by 1 each time that we do the assignment. So we just want to say set that equal to whatever the roof sprite. Oh, do we need to like globally dereference this? Presumably it's equal to this. Then we can do pix pointer +1, and then we kind of repeat this several times. But here it's not 0, it's really 4 times I plus 0. Let's just leave it like this for the time being, and then we'll simplify it when we do the assembler moving. Let's just check we can actually draw this to the screen. And then we'll draw it in a square, and then we'll finally do the assembly. Oh, we're being really silly though, since the pix pointer is not just pointing to a single byte, but it is actually pointing to an N32. Okay, yeah, this was really silly. So all we actually need to do is, I think we just need to do this. Okay, and then we are, like, I swear programming is just like writing something and then like changing it and then changing it back, and that's all you ever do. I should say low-level programming. The web is an example of why that doesn't happen. Okay. So now we want to do so let's see, we're just incrementing the location in memory by 4 each time, and each time we do that we're just pulling in the location in the kind of corresponding location in the root write memory. Okay. And then we do that 625 times. So if this compiles, when it draws, we expect just to see a bunch of lines, a line on the screen. We may have to resize the screen because Elgato is incapable of displaying this correctly, as we discovered last time. But hopefully we can avoid that. So hopefully using this new OBS way of looking at it, it should be fine. Since the programmers behind OBS clearly more competent than those at Elgato. So we want to go into the RISC-V drawing experiments. And then but we do want to make a file in Productor if we don't already have like a texture version here, but we do. Let's move this to like texture 3 actually, since it was called database last time instead of PB. So we want to do make file texture .pb or texture 3 .pb. And now we want to do compile given codecs oh, what were we even editing? we did edit texture.lbc. Then we want to write the file to productor texture 3. Not quite. I don't know anything called init sprite. Line 44. What is this? Oh yeah, setup choice just above. I do kind of, like, the more I see it, the more I do kind of like this way of laying out the file. It's taking some time. Okay, doesn't like the 4 times the I here. Internal compiler error. So why? Am I not meant to dereference this at all? I thought it was there. The type is N8. That's why. So, oops. So we're gonna have to do some casting. Presumably this is why. Why can't I scroll up and down? Is the Elgato having a whinge again? Probably is. Oh, wait, what? Why is it not showing anything? Did the Serenum crash? I can't go back to using like the freaking like Elgato capture software, piece of trash software. I don't want to use it. It's so bad. It's like slower, it doesn't render all the pixels. Okay, thank goodness, we're back. But first let's like jump to something that will make the screen 1080. So if we go to like the RISC-V and then do script or codecs, anything. No, that's not what we wanted. Okay, there we are. Okay, finally. Okay, so where were we? We were doing, we're in the codecs, and we were doing scripter on texture .lbc. And we're dealing with the fact that this thing was like indexing n8s, but we were copying here more than that. Oh, so this means we do have to do the pixel pointer thing. Let's just like try and render some pixels to the screen. So let's actually just do this. This will so we're gonna have to like cast one of the pixel pointers here to the byte pointer. So let's say like byte pointer, this is now an N8. Is going to equal to a cast of the pixel pointer and I guess if this is the case, the most sensible thing kind of is to just do that. Though I'm afraid the programming language will not optimize that, but we can get around to that. We can optimize that later. If it's going to be converted to assembly, it doesn't matter at this stage. So then we just do literally like the simplest thing, which is now just this. But now we want the byte pointer instead. Set whatever the byte pointer is currently pointing to be equal to whatever the RISC sprite is pointing to. After one. And then let us attempt to compile this. So this will be in RISC-V. Now we want to compile codecs. Was it texture.lvc? Write the out point to productor texture.texture3. Aha, it's gonna compile, and then will it run and give us what we expect? Let us see. Didn't crash, that's good. Okay, and remember we have to like view it this way. So like I can see like a red pixel there. It's really tiny, but it is there. So now I'm just like wondering why the rest of the things are not showing. Can't see that pixel moving. Okay. Full screen. Okay, so something is getting drawn there. It's just not being drawn in many places. Oh, okay, and okay, I did lots of debug messages were printing, and this is correct. We expected 2500 and we got 2500. That is good. So now what are we doing? I see. We were failing to update the byte pointer. So now we want to say byte pointer increase this by 1 as well. Move that up. Just to make life easier. Well, I feel like everything I'm going to be using is even though no. It would be good just to in the assembly will calculate what needs to be done. Okay. Oh, hang on. We need to disable this. The thing that's writing the debug. Where's the debug statement? This thing. Oops. We want to compile it, not run it. Okay, and then if we get like a line of pixels that vary in the behavior we want, we'll then do the calculations to draw them as a 25 by 25 grid. Aha, great. This is what we wanted. Okay, it's not okay, it's more obvious here when I do this. We can see the line of pixels getting drawn there. Okay. Oh, a full screen, come on. Okay, so this is working, and this is now like the easiest way of importing. This will give us the easiest workflow in terms of getting pixels, sprites in the game. We just import like the decoded bytes at the top of the file, and then call a function to draw them when we pass the pointer to it. But that will require refactoring the code it does that, and that will require actually writing such code. So let's do that now. So let's replace this dumb loop here with what? With, I feel like 2 25 by 25 loops is the easiest thing to do. So we'll have this one here, and this will be prolada, where we are just increasing I by I each time. But then for the second dumb loop, we want like a j, and here we'll need to do some like thinking ahead of time. So we'll want this j to go across every kind of pixel width, and so in this case it would be 100. Let's actually just try using this kind of way of formatting it. Yeah, this way of formatting it, it's like actually makes it easier to read when there's no syntax highlighted. Similarly here, we just want j increasing by 1 each time. Okay, and then what are we doing with regards to these locations? Let's just draw the sprite in like the top left corner to begin with. We'll move it later. We'll move it next. So when we did the disk drawing example, we had some like general calculation at the beginning to get, I think it was like the top left position of the disk, the memory position of that. And then in terms of the registers, we put the we calculated how much like it needed to jump every line down in a register, and then ended up just increasing things by that. And so I think we want to do something the same here. We want to do, there's like frame dot width. So let's see, we have this thing. Args to pass into texture drawing proc. There's like the texture height to begin with. Let's just draw like the general example now. The texture H. Well, let's call it height. Well, yeah. Your height's fine. The height here is 25. The width is also 25. We need to add in doing the XPOS and the YPOS stuff. So in terms of the I is determined by the height. But we don't need that final semicolon. Increase that by 1 each time. Each time we are doing that, we need to increase the byte pointer by the appropriate offset. So now we want to say let's just keep everything. I was going to say like N32, but that might not even work. We want this to be like the byte pointer, like next line shift. Or maybe next line offset. And so what will we want this to be? We want this to be the frame width once we've casted it. Minus the how many times we need to move back. And given that, which is going to be 25, or in other words, the width, which I think we need to cast as well. Okay. So then we need to say take our byte pointer and offset that by the next line offset. Oh, but hang on. This is not, we're not pointing to pixel chunks. We're actually, so now I think about this, the easiest way to do all of this would actually just be to cast the byte pointer as like a pixel pointer. We should just do that. That's like, it's clearly the most sensible thing to do. I don't know why that didn't occur to me in the first place. So yeah, so let's do like N32. Yeah, let's see. We'll copy this one. So, okay, some care is kind of needed here with what's happening. Like, what's the order of operations with the cast and this offset here? Given we're translating this into the assembly, I think that like we're gonna have to like manually do this we're gonna have to manually keep track of this position ourselves anyway. So I feel like this should just be a different variable. So let's do that. So likewise we can have a like roof sprite pixel pointer is now vague. I think we should have like frame pixel pointer. And now we have like a sprite. Maybe just like FR for like frame. That's fine. It's clearer this way. Frame pixel pointer. And here we actually just cast what we want. The roof sprite. And we have our next line offset all of this. Okay. So every time we go down the line when we're rendering, we are increasing the frame pixel pointer by the next line offset. Then within every individual line, we are still we're iterating over the width of the texture. And we do that, we're increasing the J by 1 each time, and we're increasing the frame pixel pointer by 4, yes, and we're increasing the sprite pixel pointer by 4 as well. I kind of like, keep it like this. Okay, and then in each of these cases, we're just doing basically a memory copy operation, where we're saying, look at whatever's in the current frame pixel pointer, and whatever that is, copy to that the 4-bit unsigned integer, i.e. our pixel, that's contained in the sprite pixel pointer location, wherever that's pointing to now. Now everything is N32s. Everything up here should be N32s. And this is also 64. Okay, let's try giving this a compile. scope is not terminated. Oops. Line 93. Yeah, this way of laying it out also makes it super clear, like way clearer when things are correctly indented or not. I'm surprised by how much I actually now like this style of laying out code. At least when I'm not using syntax highlighting. Okay, great, that compiled. Let's see if we have drawn a sprite. And if so, we can begin factoring this out. Okay, not what we intended. But also some weird colors are appearing as well. I'm not expecting to see green and other stuff. So what's happening? Like whatever I'm pushing the line by, it's like not correct. Let's end that. Why isn't that ending? Like why didn't that terminate the window? Okay. So what's happening? So the next line offset is probably the biggest culprit. Because I think we're failing to multiply things by 4. Like the width here should really be 4 times the width, and the frame width here should really be 4 times that. That would scale up the like okay, we'll see if this fixes it. I don't remember the gaps between the things that we saw being like 1/4 of the screen, right? So now I'm skeptical this is even the fix. Oh, I see. That's yeah, let's do all of this casting inside some brackets and then multiply the entire thing by 4. Okay, that was fine. Haha, and we've got our sprite right into the screen. Finally. Oh, oh my goodness. That took so long. But it's downhill from here. It is downhill from here. So now we just, we just want to factor this. Then we can even, I doubt there'll be time today for it, but we could, how much training time have we got? 1 hour. We might be able to get started on translating this into assembly, maybe. But we'll see. This is good progress. Good. This is progress. Yeah, okay, so now we have we've nearly successfully done this texture. Well, we have successfully done it. Let's save this file, since we don't yet have a version control. Copy it, and then we'll start editing the assembly version of this. So now let's make texture assembly .lbc. Let's file copy the current one we were editing over to the assembly version. And now we can edit the assembly version. So yeah, so time to do the factoring. So let's first just put this in a separate procedure. Pro C do draw sprite. What are we going to need? We want to have a pointer to the kind of the memory that's been loaded. This will just be an N8. We then want a width. A height. And then the position. Eventually it will be factored into a vec2, but for the moment it would just be an x plus and a y plus. Okay, then we want to use the above and adapt it at the same time. So let's copy this, paste it in here, and replace all of this with actually, I'm just thinking, any kind of assert we do, we should probably just do that assert once we call it, just to check that the width stuff that's getting passed in is sensible. Okay, so now we can say draw sprite, and here we want our roof sprite. Save. Okay, so these width and the heights are now given. Oh, hang on. We're going to have to pass in these extra parts. 25, 25, and let's draw this kind of in like the center of the screen. So it won't be the actual center, but the top left pixel coordinate could be the center of the screen. If we wanted to do that, it would have to be 400 and 300. Okay. So yeah, these heights, whatever. So now we need to calculate the actual frame pointer. So let's see. I think we want to have like frame width. I certainly don't want to be passing in like the frame as a procedure into this draw sprite. I think we want to do the calculation beforehand of where we want I think we want to pass in the like maybe it actually is fine just to pass in like the frame. It is just the structure pointers. And yeah, this isn't code I want to replicate each time. Okay, I think we will pass it in. What even is like the type of it? So it's a new frame type, new. We somehow avoided this in the disk drawing function. Like, what did we do with that? I'm curious. Like, what actually did we pass into that? Where's disk ASM? Did we supersede it? Okay, so our kind of function, like procedure prototype was, yeah, just like the new frame, the X and Y, the radius, and the color. Okay, I think we'll do something similar. And we call it next line int. Okay, let's just like copy all of this stuff. Quit scripter m texture ASM. I guess we kind of do want this to be a public procedure. Like, is this the most sensible coordinates? I think this is fine, yeah. The frame where we're putting it, let's just call this like top left X and top left Y, just so it's clear. And then we can have the width and the height. We might even create a struct later to do this. Like, yeah, having a struct that just says, this is like a texture, this is the location of the pointer to its bytes, this is how wide it is, this is how high it is. I think that's kind of all we need, maybe a name. That could simplify a lot of this. I think we will end up doing that. That would be quite good. It would make calling this significant, like this would make calling this so much easier. You just say, this is the frame I want to draw it in, this is the X and the Y coordinate, this is the texture. That's it. Make a struct for textures. For the moment, we'll continue factoring. So yeah, the X, the top left X, top left Y, the height, and then the sprite pointer, which is an NA sprite pointer. Yeah, so then we want to do our frame pointer calculation here. The frame pointer is going to be the frame.pixels and then all of these offsets. So since we're not doing these with the radius, it's a bit easier now. We want to multiply the frame width by the top left Y, and then we want to add in the top left X. Then we want to multiply everything by 2. These parentheses seem correct. Cast that to an N32 and offset it. Great. And then the next line increment is now the frame width minus the texture width. And maybe this should just be called like T width and T height. No, it's fine. These are fine for now. But if these are going to get wrapped up in a struct, whatever. I'm gonna have to rewrite them anyway. Okay, so we do that, and then let's just change how we're calling this to match what we just wrote. So we have our frame, the top left x, the top left y, the width, the height, and then the sprite pointer, which is what, roof sprite. Okay. Okay, so these ones we can nearly do away with. This one we also want to calculate up here. So it's the frame pointer and then the sprite pointer. I feel like frame pixel pointer is really better. Now we've done that, we can get rid of that. So now it's just the actual stuff. So yeah, we iterate over this like texture height. The frame pixel pointer gets incremented by the next line increment. Do that with the width, do that, and then I think that's kind of it now. Everything should be properly indented there. Okay, let's try and compile this. So now we want to compile, oh actually, we're going to have to write out some new, we're going to have to make some new files. Let's make one called like texture ASM. Make file texture asm.pp. Now when we compile this, we want to compile in the codex compile texture assembly.lbc. Send this to texture asm.pb. Nota comaque distinct declaratorium parametry best. Oops, I somehow forgot to do that, even though I thought I did. Okay, that's compiled. Great. Let's see if it runs and draws it near the center of the screen. Haha! Fantastic. Great. This is really good. The game is coming along. It is coming along. So now so now we factored that. We now want to think about moving it into assembly in some way. That's going to take a while, longer than I want to stream for today. So maybe we actually create a struct first. Well, it depends. For 90 minutes. Yeah, let's like copy in. Yeah, copy in like, because I've forgotten how to do structs in this language. Let's copy in. Then let's do the struct. I think there'll be time for it. So we can go to our Sokoban, our codex for it, and open up. This time, just read only the Sokoban source code. And how do we do the structs? It's as simple as this. Okay. Is that the most complicated struct we have? Seems to be. So yeah, so let's make this structure. So call this like sprite. We want this to have a width. Well, really, the very first thing should be a pointer to where it actually is. So let's say like sprite pointer. Then the width and the height. Okay, save. Okay, and now we want to like initialize one of these. So how do we do that? I've forgotten how to do this. Let's check out our Sokoban source. Well, we have done this many times. When we like set our, oh, interesting. Okay, so this is the car pause. Is it simply like declare it on one line and then set all of like the dots in another? Well, I've forgotten how much game code has gotten written over the course of this project. Yeah, it's just like dot. Maybe there isn't any way to like initialize it in some easy way. Like you just say assign this assign like I'm declaring this thing, assign memory for it. This goes here. This goes here. We'll do that. Okay. So let's do. So yeah. No, it's frozen again. OBS. Come on. No, well, it's we know who the true culprit is. Luckily, this time it froze on the. While it was in 180. Wait, why can't I just delete this? Yes. Video capture. Oh, wait, why isn't it loaded? Like, come on. Okay, good. Okay. Let's see, RISC-V, scripter M, texture, really codecs, scripter M, a texture, ASM, get that on the screen. Then that's right. We should probably load like the sprites here. Load the sprite. In the actual game, we might just like assign globals for these, and then do things that way. So how do we want to do this? We want to say sprite roof tile, and then we want to say a roof tile dot. We just set these things. The sprite pointer is equal to what was it? What did we call it as? Roof sprite. Okay, roof tile is a bit, well, roof tile feels a bit vague. What if we call it like sprite roof tile sprite? Really, it should be the roof sprite. Okay, if we call this roof sprite data, we don't really need to call it like the tile. We can just now call this the roof sprite. And then the pointer is going to the roof sprite data. Roof tile dot width is 25. Likewise, the roof Dvorak, rather like the QWERTY keyboard. It's a dead man walking. It's going to take centuries, but it will be dead. Okay. Okay. So now we've done that. Let's just try and compile it and see if something has gone wrong already. RISC-V drawing experiments. Compile. Give me codecs. Texture. ASM.bc. Productor. Texture. ASM. Aha! I knew something was gonna go wrong. Roof tile. Right. It really should be called roof sprite. compile again. Oh no, another one. Expected at n8 got structure a sprite. Oh yeah, good. This is what is expected, since now we need to actually refactor the drawing the sprite code to do what we wanted. But otherwise it seemed to pass. So now we can like get rid of all of this and just replace it with sprite. Sprite. And now here we need to use our structure. So we have our sprite pointer and the width and height. So the frame pixel pointer is fine. The sprite pixel pointer is now needs to be modified. So now this is sprite dot sprite pointer. The next line is now increment. When we subtract the width, it's now the sprite width. Oh, is that kind of it? No. We need the sprite height here and the sprite width here. And now we can get rid of those parts of the argument too. Okay, let's try compiling this now. Okay, now let's try and launch it. Texture ASM. Aha! Fantastic. So now we can draw that sprite easily. Let's just draw like many of them at once. Now we've done all of the hard work to work out how to do this and wrap it in an easy procedure. So let's draw like 5 or something, or 4. Let's draw one here, one at like 200, one at like 450, 100, and one at like 50 and like 400 or something. Okay, let's compile this. Great. Okay. We are now very close. Well, we're now in the position to be able to draw graphics in our game, sprites in our game if we want. This kind of looks, this is not the correct width because it's being stretched. What if we actually rendered this as like 1080? I want to just see it slightly crisper. So what if in terms of the mode we have like mode 3 here instead. I want to be able just to like see it in a nice way. Why did I do that? I have to wait another 10 seconds, 12 seconds. Okay, cool. It's a tiny, but they are crisp on the screen. Alright, this is great. And these are now like not stretched and the correct width and everything. Okay. So yeah, this is certainly enough progress for today. Time for me to go back to the fun of DirectX. This is way more fun than that. Actually, kind of like doing it in Zig and being one of the first people to do it in Zig is it is satisfying in its own way. Even if it is just calling procedures from Zig that I was going to say hundreds of thousands, but maybe it's only tens of thousands of people have. This is a good question. How many people have actually used the DirectX 11 API? 10,000 plus or 100,000 plus? I feel like it's more than 100,000 plus. Anyway, so yeah, let's quit out of this, back up everything on the Serenum, and call it a day. So. I feel like we're now two more streams away from getting the stuff in our game. Next time we'll be writing the quick assembly version of this. Then we might have to do like another drawing stream where we can draw like an ocean tile or something. And then, oh, who am I kidding? Let's just like, the next stream after that, we'll get it in the game. And then we can expand tiles as needed. So we're doing Serenum backups. What's today? Serenum 6, 2024. September the 16th. And let's like copy that over. Okay. That's all done now. It's back in the Serenum. Okay. Okay, great. So yeah, thanks everyone for stopping by. I was happy with the progress we made today. Yeah, it's very satisfying being like the first person in the world to be drawing textures. Okay, the second person in the world to be drawing textures to the Serenum and making a game which is not just Pong or something on the Serenum 2. But yeah, it's also like it's fun to be just like doing graphics like unlike DirectX 11 or any other API for that matter, where to even just like make the background of the screen blue, it's like 10 hours. These days it's even worse with Vulkan. It's like 100 hours at least. It's nice just to say this is a pointer to a pixel on the screen. Put that color there, and that's all you have to do. So yeah, way easier. But yeah, thanks everyone who stopped by. Happy programming, and I'll see you next time.